Hi everyone, so welcome back in my again YouTube channel, and today's topic is that we are focusing on three-phase AC circuit, because most of the time the three-phase AC circuit feels a complicated topic for every student. So basic motivation behind this video is to focus the theoretical concept of three-phase AC circuit. So we know that generally we say that single phase and three phase are the two types of supply, but India we generally generate the three-phase AC supply, and then at consumer end we can convert it as a three-phase and single phase. That's why the knowledge of three-phase AC circuit is more important for us. So today's video we will focus what is the generation of three-phase AC supply, then what are the advantages of three-phase AC supply, and then two important connection in three-phase AC supply. They are known as star and delta connection. So that is a focus behind this video, and that's why this video stands, that is three-phase AC circuit, a theoretical part. So first point that is we focus on, so topic name is three-phase AC circuit. Three-phase AC circuit. So basically first point in three-phase AC circuit, what is the generation concept of three-phase AC supply? Generation of three-phase AC supply. So as we know that it is always take place by Faraday's law. So I'll give the schematic diagram, that is how generation of three-phase AC supply take place. So generally we use one N pole. This is just a basic concept, and S pole basic function is to create the magnetic flux. But in single phase AC supply we use only single winding, or you can say single conductor. So there are only one winding in single phase, but in three phase there are three windings. So that winding I represent as a conductor only. So first I'll take the first conductor, that is known as R and R dash. So R and R dash is my first conductor. R and R dash is my first conductor which is rotating inside the magnetic field. But after R and R dash or R winding, next job, that is we have to go for the Y winding, that is 120 degree apart, because we have total pace of 360, then we have to utilize that pace. That's why second winding is Y dash, and which is displaced by angle of 120. So I roughly say this is my second conductor, that is known as Y, that is Y dash. So this is the Y and Y dash, and angle between R and Y is roughly 120 degree. How much? It is 120 degree. And after Y, then we have to go for another winding that I represent as a conductor, and that winding is known as blue winding, yeah, B phase winding, and that is also shifted by angle of 120. So this is suppose roughly structure of your B conductor. This is a B conductor, that is B and B dash. B and B dash. So angle between Y and B is 120, and angle between B and R is 120. So simple word may, that is Y phase is lagging by 120 degree. From Y, B phase is lagging by 120, or you can say from R, B is lagging by 240, or in another word, B is leading by 120 degrees. So this is a representation of three winding I shown as a conductor. So three conductors, when you rotate simultaneously inside the magnetic field, when you rotate these three conductors simultaneously inside the magnetic field, there is generation of three waveforms. There is generation of three waveforms. So what is the nature of that waveform? We will see now. So how the three waveforms are take place. So first waveform, first conductor cut the magnetic field, and there is generation of EMF, and according to Faraday's law, this is your generation of single phase AC supply, and this supply roughly denoted by VR. An important point, that maximum value will be the VM and negative maximum value is minus VM, and this is again a 0. So this is my R conductor will generate the waveform, and mathematically if I represent, then VR always equals to रहेगा VM sin omega t, sin omega t, and angle point of view VM का angle हमेशा हम मानेंगे reference, that's why it is VM at an angle of 0. So this is my first waveform take place, that is called as single phase AC supply. But after 120 there is a Y conductor. So what will be the waveform generated by the Y conductor? Y is a lagging, and we know that lagging phasor always start from negative. Lagging phasor always start from negative. That's why this waveform start late, and then it also follow the same rule. And this is your VY conductor. But what is the important point in VY conductor? It is lagging behind by angle of 120 degree, lagging behind angle of 120 degree, and that's why it is become Vm at an angle of minus 120 degree. So this is my second waveform. Due to the rotation, there is a generation of another supply that is called as Vy, and after 120 there is another conductor called as B conductor, and if you rotate this B conductor by 120, then B conductor develop another waveform, and that nature is leading. That's why start from positive and then it follow the same sine law, and this waveform we denote as a Vb, and Vb always equals to रहेगा Vm sin omega t minus 240, and that is equals to Vm at an angle of minus 240. Important point here that all three waveforms have equal in magnitude, that is Vm and minus Vm, but important point, they are having phase displacement angle of 120 degree, and this is the meaning of three-phase supply. So what is the important point phase stands for? Basically phase stands for number of winding or number of conductor. In single phase generation we use only one winding, that's why it is called as one phase supply. But in three phase we are using three conductor, that's why we will get three different waveforms R, Y, B. That's why this supply is called as three phase, matlab we are using three conductor. So in AC, phase always stands for number of winding used while generation. If you use one winding, then supply is called as single phase. If you use three winding, then supply is called as three phase. So this is the basic behind generation of three phase AC supply. And if you draw the waveform, phasor diagram, then R conductor will remain on angle of 0. So this is your R conductor, that is called as VR. After 120, there is Y conductor, that is known as Vy, and after 120 there is a B conductor, that is known as Vb. So this is a roughly phasor diagram for three-phase AC supply. Each conductor is lagging behind 120 degree, again 120 degree. So this is the phasor diagram for three-phase AC supply. Phasor diagram for three-phase AC supply. So once again I repeat, this is a generation principle. When you rotate three conductor R, Y, B by angle of 120 inside the magnetic field, there is generation of three waveforms which obey sine law perfectly, known as three-phase AC supply. We are start from 0, that's why angle is 0. Vy is lagging by 120, that's why angle is minus 120, and Vb is lagging by 240, that's why angle is 240. And if you see in phasor diagram also, they are continuously displayed by angle of 120 degrees. So this is the basic behind generation of three-phase AC supply. Now the important point, what are the advantages of three-phase AC supply? So if you observe here, if I use this only one conductor, then I will get only one waveform, and that's why the first advantage of three-phase supply, that generation cost reduces. Matlab it is economical to generate the three-phase supply, because instead of one winding we are utilizing three winding, that's why we will get three-phase supply. That's why first advantage, that generation of three-phase AC supply is more economical and efficient than the single phase. For example, if I am driving the car and I am a only person, and if I carry the three more person with me, then automatically my cost and everything will be saved. That's why generation of three-phase AC supply is more economical and efficient. That is the first advantage. If generation is economical, then we can say transmission is more economical. Transmission is also more economical. And third important point, if there are three waveform, it will generate more power. And that's why three-phase supply, fourth advantage, that it is suitable for industrial and domestic load application. That's why in India we generate only three-phase supply. So we list out what are the advantages of three-phase supply. Advantages of three-phase AC supply over single phase. The first advantage, that is generation. Generation is more economical and efficient. Why? Because I already explained, due to use of three conductor instead of one conductor. So generation is more economical. Then second advantage रहेगा, that is a transmission. Transmission is also economical, because we are generating three phase, means we are transferring the three phase supply. And as there are three waveform, that's why three phase AC supply has more power. AC supply have more power, has more power than single phase. So another advantage, that it develop the more power, and that's why it satisfy industrial, it satisfies the industrial and domestic load requirement. Domestic load requirement. So these are the advantage of your three-phase AC supply. That's why in India we generally use the three-phase AC supply, and at end we convert it as a single-phase AC supply. Okay. So next topic in three-phase AC circuit, we already discussed the generation of three-phase AC supply, and now what is the next part in three-phase AC circuit, that is what type of connections are there. So simple, in three-phase AC circuit, as blackboard indicate, there are two types of connection. One is called as a star connection. In DC circuit we are already familiar what is the meaning of star connection, and second connection is known as delta connection. So two connections possible in star and delta connection. So in exam generally theory point of view, there may be one question, that is derive voltage and current relationship in star and derive the voltage and current relationship in delta. So out of two, any one derivation they generally ask what kind of voltage and current relationship in star and delta. So now we'll focus on first part, that is what is the voltage and current relationship in star connection. So voltage and current relationship in star connection. Voltage and current relationship in star connection. So this derivation you have to do, because most of the time students feel that it is very complicated, but if you go step by step, and want to request to all of you, that is you draw simultaneously with me, then things become easy for you. So first job inside it, that is you have to create the circuit diagram. So first job, that is what is the meaning of circuit diagram, how connection styles take place. So for example, in your building or in your society, there may be the load, that is A wing, B wing and C wing. Then generally connection is like that. Star means three common points are connected together. So this is my load number one, I say it is R phase load. This is my another phase, that is I can say Y phase load, and this is my another load, phase load, that is called as B phase load. So this is my basically connection, and common point in star connection is always called as neutral. That's why in our house there is a phase and neutral concept. So R, Y, B, this is your three phase, this is your three phase star connected load, three phase star connected load, and this three phase star connected load, if I connect now to the three phase AC supply, which is also described by in generation we are already familiar, that is R, Y, B. So this is your three phase AC supply, and connection style is so simple. If you connect R to the R, Y to the Y by keeping phase sequence same, and B to the B, so simple circuit diagram for star connection. R, Y, B, this is your three phase AC supply, this is your three phase star connected load, and three phase star connected load is connected across three phase delta star connected load is connected across three phase AC supply. Now what is the question here? Derive the voltage and current relationship in star connection. The most important point, that is what are the different types of voltage available in star connection. So first concept in three phase, that is called as line voltage. Concept is called as line voltage, and this line voltage is always denoted by VL. Line voltage. So what is a line voltage? Basically, if I take one voltmeter in my hand and if I measure voltage between my first line, that is R and Y, then that voltage is always called as VRY, because I am measuring voltage between R and Y. Similarly, if I measure voltage between Y and B, that voltage is called as VYB, and keeping phase sequence same, if I measure voltage between B and R, that is B and R, then this voltage is called as VBR. So I get three voltages on supply side. One is known as VRY, another is known as VYB, and third one is known as VBR. So what this voltage now says, this voltage is voltage measured across supply line, and that's why these voltages are called as line voltage. So what is the concept of line voltage? It is simply voltage measured between any two supply line, and that's why if I denote here, that is VRY, that is equals to VYB, that is equals to VBR. All three are known as line voltages, known as line voltages, and they are denoted by the VL. The first important concept in three phase, that is a line voltage. In simple word, it is voltage. It is a voltage measured. It is a voltage measured across any two supply line. Any two supply line. तो आपके पास supply line कितने हैं? How many supply lines are there? 3 supply line. That's why in three phase there is always 3 line voltage. How it is denoted by capital word? VRY, VYB and VBR. So this is the first concept in three phase, the line voltages. Another important concept is there, that is phase voltages. After the line voltage, if you want what is a phase voltage, then try to come on the load side. Whatever voltage measured on load side is always called as the phase voltage. For example, if I measure voltage between R and N, then it is become my first phase voltage, that is called as VRN, because you are measuring between R, one phase and neutral. Second voltage if I measure between Y and B, then it is called as VYN, and third voltage if you measure between B and N, then it is called as VBN. So how many voltages are there on load side? 3 voltage. Voltage measured between R and N, voltage measured between Y and N, and voltage measured between B and N. That's why second important concept of three phase, that is called as phase voltage. Phase voltage, and this phase voltage is always denoted by VPH. How it is denoted? VPH. And three phase voltages are there called as VRN, that is equals to VYN, that is equals to VBN. All three voltages are known as the phase voltages, and phase voltages are always denoted by VPH. Second important concept of three phase, that is phase voltage. So how you define the phase voltage then? Phase voltage is voltage measured across measured across the respective phase load. How many respective phase loads are there? 3. That's why in three phase there are 3 phase voltages: VRN, VYN, VBN. So this is about the voltage relation. Voltage first is line voltage, second is phase voltage. Next concept in three phase, they are called as the line current. Now observe here, 3 supply lines are there. If I say current delivered by R line is IR capital, current delivered by Y line is IY capital, and current delivered by B line is IB capital. So whatever current delivered by each supply line, they are called as line current. So तीसरा concept रहेगा line current. तीसरा concept is known as line current, and they are denoted by IL. That's why IR capital, that is equals to IY capital, that is equals to IB capital. All three are called as line voltages, and they are denoted by IL. They are denoted by IL. That is a line current, IL. तीसरा important concept. So how many supply line are? 3. That's why what is the definition of line current? It is current delivered by each supply line. These are called as line current. So in three phase there are 3 line currents because there are 3 supply line, and the last important definition remain the phase current. Now what is the meaning of phase current? Phase means you have to come to the load side, line means you have to come to the supply side. So phase side, how many phase are there? 3. So if I measure now current taken by my R load, then I can say it is IR small. Current taken by Y, I can say IY small, and current taken by B, I can say IB small. And that's why if I say the last concept, that is called as phase current denoted by IPH, then IR small, that is equals to IY small, that is equals to IB small. They are called as phase current. They are called as phase currents. 3 phase load are there, that's why they are phase current. And what is the definition of phase current then? Phase current is nothing but current taken by respective load respective load. This is the definition of IPH. So in three phase, this is the introduction parameters of three phase connection. So once again I repeat, if I take supply side, then supply side three lines are there. We measure the three voltage VRY, VYB and VBR. They are called as line voltages. If you come across the load side, VRN, VYN, VBN. I am measuring voltage across load, then that's why they are called as phase voltages. If you measure the current delivered by each line, IR, IY, IB. So current delivered by each line is called as IR capital, IY capital, IB capital. They are called as line currents. And if I measure the current taken by respective phase load, then IR, IY and IB small are called as phase current. So how many quantities are there in three phase? 12 quantity. 6 quantity towards supply side, 6 quantity towards load side. And in exam, generally the question that is how you correlate the line parameters with phase parameter, and that is a question, explain voltage and current relationship in star connection. So now it is time to think about the relationship. So consider the same circuit diagram, and now I want to derive the relationship. So first line voltage I am taking. First line voltage, that is VRY. यहाँ थोड़ा सा ध्यान देना है because this is the most important concept in derivation. VRY. What is the concept? Parallel voltage always remains same. So supply side VRY is load side this VRY. VRY. Calibrate from the load side. So it is surely हो जाएगा VRN plus VYN. Sorry, VNY, because phase sequence should be same. So I write here VRN plus VNY. Why NY? Because calibrate from here. R to N, VRN, N to Y, VNY. But we want in terms of VYN, then how? And most important, they are phasors. That's why if you correlate, then VRY equals to हो जाएगा VRN, और अगर Y के टर्म में चाहिए तो VYN, but important point sign remain minus. So this is the first important relationship you have to derive from the circuit diagram. So what is this relation says? VRY. What is a VRY? Line voltage. What is a VRN? Phase voltage. What is a VYN? Phase voltage. So what is a line voltage? Equals to phasor summation of, yes, phasor subtraction of two phase voltages. Two phase voltages. So this is the first relationship. Take the another line voltage VYB. This is a VYB. Parallel, if you check, this is V and Y. Calibrate from the load side. So it is VYN. VYB equals to, it is VYN. VYN. And if you go here, then VNB. It is become VNB. And it is a phasor summation of these two. And if you write in terms of first parameter, then VYB equals to VYN minus VBN. Minus VBN. So again, if you observe here, can I say what kind of relationship develop here? In this case, relationship is again same, that is line voltage is phasor subtraction of two phase voltages. So even if I take VRY, same expression, VYB, same expression, and if you derive for VBR also, you will come across the same concept that in three phase line voltage is phasor subtraction of two phase voltages. So this is the most important point you have to derive from the circuit diagram. What is the concluding remark? That is, line voltage is a phasor subtraction of two phase voltage. This is a become theoretical statement, but we want actual value. What is the value, or what is the relationship between line and phase? For that, if you observe this connection, you have to draw the phasor diagram, because without phasor diagram, you cannot get the answer for that. So now we'll try to develop the phasor diagram. Try to remember these two equations, 1 and 2, VRY and VYB. So how to draw the phasor diagram? Now concentrate the phasor diagram of star connection. Phasor diagram for star connection. Phasor diagram for star connection. when you draw the phasor diagram for star connection, first job that by generation concept you have to take 3 phase voltage by angle of 120. So this is my first phase voltage, I denote by VRN. This is my second phase voltage, I denote it is by VYN. And this is my third phase voltage, I denote it is by VBN. So how many and they are rotating? This is my 3 phase voltages by angle of 120. Why? Because in generation we already see that in 3 phase 3 voltages are at an angle of 120 degree. So this is the first job you have to do when you draw the phasor diagram. Now correlate, remember what relationship we got from the connection diagram. पहला relation मिला था VRY equals to VRN minus VYN. This is the first relationship we got. And second relation था VYB equals to VYN minus VBN. So this two relationship we got from the circuit diagram, and now we want to correlate these two relation. So please observe these two equation. In both the equation we have VRN, we have VYN, but we want minus VYN and minus VBN. So only take two vectors minus. What is the meaning of minus? Minus means that shifted by 180 in phasor. That's why I want minus VBN. So can I take minus VBN here? This is my reverse phasor, minus VBN. And where is the minus VYN? Minus VYN will be go on this side. That is called as minus VYN. So two phasor, VBN and VYN. What about phasor summation? If I want VRY, what is the VRY? My line voltage. If I want VRY, then what I have to do? I have to join them by law of parallelogram. Why law of parallelogram? Because angle is not 90 or angle is other than 90. So if we join by law of parallelogram, this is my law of parallelogram. If I join them, I'll get my first line voltage, and that line voltage is denoted by VRY. If you cross check the angle, if it is 120, then this angle surely becomes the 60 degree. Surely becomes the 60 degree. If you take one relation also, you can easily derive the relationship between these two. So 60, and if I apply law of parallelogram here, what is my resultant here? Resultant remain VRY square, that is equals to पहला पैरामीटर रहेगा VRN square, दूसरा पैरामीटर रहेगा VYN square plus 2 VRN VYN cos 60. VRY square equals to VRN square plus VYN square plus 2 VRN VYN cos 60. Now try to convert this equation in generalized term. What is a VRY? VL square. What is a VRN? VPS square. What is a VYN? VPS square. And what is a 2 VRN VYN? 2 VPH square, and cos 60 हमेशा रहेगा half. If we simplify, then VL square equals to हो जाएगा 2 get cancel. It is become 3 VPH, and from that VL equals VPH square. From that VL equals to बनेगा √3 VPH. That is the first point. Or you can say VPH equals to VL by √3. VL by √3. So this is the most important relationship in star connection. Star connection. So what is the voltage relationship? Voltage relationship रहेगा VL equals to √3 VPH or VPH equals to VL by √3. Now that's why if you come across the previous slide, then observe here that in society generally we take the 3-phase supply and we use the single phase supply. What is a single phase supply? घर में दो पॉइंट आते हैं, वन को कहते हैं फेज और एक को कहते हैं न्यूट्रल. तो सपोज आपके घर में एक फेज न्यूट्रल आया है, तो फेज न्यूट्रल के अक्रॉस कितना वोल्टेज आएगा? VRN. व्हाट इज दैट VRN? VPH. एंड दैट इज इक्वल्स टू क्या डिराइव हुआ था? VL by √3. इसलिए अपना सप्लाई रहता है रफली 400 by √3, क्योंकि 3-phase सप्लाई हमारा रहता है 400 का, तो घर का सप्लाई बन जाता है 230 वोल्ट. एंड दैट्स व्हाई we are using 230 volt single phase AC supply in domestic application, because we are connected in star. In building, if there is a 3-phase supply, one wing act as a R phase, one wing act as a B phase, one wing act as a Y phase, and we have one phase and one neutral, then it is get 230 volt as a phase voltage. And those who want the larger power application, they can use the 3-phase supply. This is the beauty of star connection, because star connection gives you single phase supply also as well as 3-phase AC supply. So what is the next point? That is a relationship. रिलेशनशिप क्या मिला हमें स्टार में कंक्लूड करने के लिए? इन स्टार कनेक्शन लाइन वोल्टेज ऑलवेज इक्वल्स टू √3 VPH एंड द एक रिलेशनशिप बाकी रहा करंट का. Please cross check here. What is the line current? IR. What is the phase current? IR small. Can I say they are series? And if they are series, they remain same because series current always remains same. What about IY? IY. This is also IY. This is also small IY because they are series current. This is my IB. What is this? This is also IB. They are also series current. So there is no difference in current because it is a series connection. That's why VL equals to VPH, but IL always equals to रहेगा IPH. This is the most important point. Voltage and current relationship in star connection. So what is the conclusion? In three-phase star connection, line voltage always equals to √3 times phase voltage, and line current equals to phase current. So now we already observed what is the relationship in star connection. Now it is time to go for another important question in three-phase. What is the voltage and current relationship now in remaining connection, that is called as a delta connection. So what is the question? Derive the voltage and current relationship in delta connection. So first job, that is draw the delta connection. You already familiar to the DC. What is the meaning of delta connection? So when you join 3 dissimilar points together, so I am again taking the 3 terminals. One is called as R, then called as Y, and then called as B. And if I look at the load, so this is my L, load in one phase. This is the second phase load connected to the B, and this is the third phase load connected to the this one. And if I mark the terminal marking, that is R, Y, and B. So this is my three-phase delta connected load. So first job, you have to draw the three-phase. This is your three-phase delta connected load. Delta connected load, three-phase delta connected load. And now this three-phase delta connected load, if you connect across three-phase AC supply, that is R, Y, and B, such that R connected to R, Y connected to Y, and B connected to B. So this is so simple circuit diagram because this chapter is very simple. So this is a simple circuit diagram, and what should I write? This is my three-phase AC supply. This is my three-phase AC supply. So in three-phase AC supply, this is my three terminal R, Y, B, three-phase AC supply, and this is R, Y, B. So what is the difference between star and delta? In star there is a neutral, but delta there is no neutral, it is a close connection. So only R, Y, B terminal marking is there. Now again the question is same, how you derive the voltage and current relationship in star. So again same concept, whatever concept we use in star, same concept we have to use in delta. So first try to measure between R and Y, then it is called as VRY, that is my first line voltage. This is my second line voltage called as VYB, because I am measuring voltage between Y and B, and third voltage is remain VBR. So any change? No, because supply side remains same. That's why 3 line voltages are here, again the same, VRY, VYB, and VBR. So first point you have to write here, that is VRY, that is equals to VYB, that is equals to VBR, and all 3 are known as the line voltages. So how many line voltages in star? 3. How many line voltages in delta? 3. And how line voltages are denoted by VL. So first concept, 3 line voltage, because what is the definition of line voltage? We already defined, it is voltage measured across supply line. Now come back to the load side. As there is a node neutral, that's why minor terminology change take place. That is, if I measure voltage across R and B, then it is become VRB. I am writing in small letter case so that there should not be confusion. If I measure between voltage Y and B, then it is VYB small, and if I measure voltage between B and R and Y, then it is VRY small. VRY small. So generally show the phase voltage in smaller letter case. So it is VRY small. So 3 voltages on load side. First is VRY, VYB, and VBR. Keep the phase sequence same. Phase sequence same. That is VBR. So 3 phase voltages. First is VRY, VYB, and VBR. So second important concept in delta, that is VRY small, that is equals to VBR, VRY small, then VYB small, and that is VBR small. All three are called as phase voltages, and these phase voltages are always denoted by the word called as VPH. Second important concept in three phase, that is the meaning of phase voltage. Now before we go ahead, if we try to correlate the line and phase voltage, you already familiar line voltage, we already familiar the phase voltage. Please cross check here. If I say this is a VRY, and if I take parallel terminal here, this is also VRY. So can I say VRY is a small VRY because parallel voltage remains same? That's why VRY capital equals to always VRY small. Why? Because they are parallel voltage. If I cross check VYB, then it is surely VYB because parallel voltage remains same. So VYB always capital equals to रहेगा VYB small, and VBR capital, that is always equals to VBR small. Please cross check here. VBR capital equals to VBR small. Why? Because they are parallel voltages. They are parallel voltages, and parallel voltages are always remain same. Parallel voltage always remains same, and that's why if you generalize in this term, then these three terms are called as line voltage, and these three terms are called as phase voltage. So what relationship you got in delta? Line voltage equals to phase voltage. Exactly reverse. In star, voltages are different, but in delta, line and phase voltage remains same. So this is the half part. What is the meaning of voltage relationship in star? Now you have to think about the current. Third parameter, I am defining the current. Same concept here. If I define current of this line, then it is IR capital. Current of this line is IY capital, and current of this line is called as IB capital. So what I have to say here? IR capital equals to IY capital equals to IB capital. Can I say they all are called as line currents? All are called as line currents and denoted by IL. Same concept here about phase current. If I define the current of this branch, then can I say this current remain IRY because current is passing from, this current is passing from define the three clockwise current first. So if I define the current of this line, this is a clockwise current, this is also clockwise current, this is also clockwise current. So what is this current is called as IRB. What is this current? IBR. And what is this current? IYB. So these three are known as phase current. That's why IRB, that is equals to IBR, IRB, that is IBY, and then IYR. IYR are always called as phase current, and they are denoted by IPH. So this is another concept: line voltage, phase voltage, line current, phase current. Now if I want to derive the relationship between these two, then if you derive the two equations similar to the star, apply KCL at node R. If you apply the KCL at R, please observe here what is the incoming current? IR capital. What is the outgoing current? IRB. What is the another incoming current? IYR. So I take it is IYR on this side. So दो करंट आ रहे, कौन से दो करंट आ रहे? IYR आ रहा है, IY भी जा रहा है और IR आ रहा है. That's why IR plus IYR, that is equals to IRB. From that if you correlate, then IR always equals to रहेगा IRB minus IYR, phasor subtraction. IR equals to IRB minus IYB. Same relationship. What is this IR? Line current. What is this IR? Line current. And what is this two? Are phase current. So same relationship. Line current equals to phasor subtraction of two phase current. And to derive the relationship, again we have to go for the phasor diagram, because again there is a phasor subtraction. That's why draw the three phase current now. In star, what we have done? In star we have draw three phase voltages. Now you have to draw the three phase currents, IRY, roughly IYB and IBR. And if you take any one phasor just to show purpose, this is minus IBR, and if you join these two together, then you will get first line current like the star, and that line current is called as suppose IR. And angle again remain the 60 degree. So can I say it is your IPH? अगर नाम याद नहीं रह रहा है तो simply कहो IPH, यहाँ भी कहो IPH, और यहाँ simply कहो IL. That's it, enough. So IPH and angle remain equals to 60. And if you apply log parallelogram now, then IR square equals to क्या रहेगा आपका IPH square plus again IPH square plus 2 IPH square cos 60. And if you simplify, then IR को मैं कहूंगा line square equals to क्या रहेगा 3 या directly 3 IPH square equals to क्या हो जाएगा IPH square plus again IPH square plus 2 IPH square cos 60 होगा half of get cancel, तो IL square equals to होगा 3 IPH square. From that IL become equals to root 3 time IPH, or we can say IPH equals to IL by root 3. Same relationship in star, and star में रिवर्स हो रहा है, डेल्टा में रिवर्स हो रहा है. That's why what is the final statement for delta connection? In delta connection, what relationship you got? VL become equals to VPH, and what about line current? IL equals to root 3 IPH. So that is the meaning in delta connection. So in three-phase delta connection, line voltage always equals to phase voltage, and line current equals to root 3 times phase voltage. Exactly reverse about star and delta. So this is the important derivation, star connection and delta connection. Meaning remain almost same. In star connection, what is the line voltage? Root 3 times phase voltage. In delta, line voltage, phase voltage are same, and line voltage and phase voltage are same. That's why this connection is more suitable for industrial application, because it delivers more voltage and you can say more power. But in star, we'll get VL equals to root 3 VPH, that is suitable for domestic application, and about current IL equals to रहेगा IPH. Now we'll do the comparison between both star and delta connection. Sometimes they ask the question, derive the relationship between star and delta. Star and delta. So in exam for 4 marks, if they ask the question, derive the relationship between star and delta. So first, if possible, draw the circuit diagram. So this is basically a star connection. This is basically a star connection, common load, and this is a 3-point called as R, Y and B. Common point रहेगा आपका neutral. This is the nature of load. And this load, if you roughly show, connected to three-phase AC supply sufficient with R, Y, B. So this is my star connection diagram. Common point is called as neutral. And what about delta? Same job about delta. 3 terminal, you can say R, Y and B. This is your delta load. Delta connected load Y, and this is B. And you can same connect to the supply R, Y and B, or you can connect Y here, B here, meaning remains same. So this is my RYB, 3-phase AC supply, and this is my delta connected load. So first comparison, if possible, draw the circuit diagram and show that this is my star connection load, this is my delta connection load. Next comparison रहेगा in star connection, what is a VL equals to root 3 VPH, or VPH equals to VL by root 3. VL by root 3. But what about in delta connection? VL simply become equals to VPH, and IL equals to become root 3 times IPH. So this is another important. So that will take in next comparison. So what is the VPH equals to? VPH equals to VL. What about current? Can I say in current there is no relationship? Simple, IL equals to IPH in star. But what about in delta? Delta में surely क्या हो जाएगा? IL equals to IPH. तो opposite side क्या हो जाएगा? IL equals to root 3 times IPH. तो तीसरा comparison हो जाएगा star and delta में. Power formula remains same. So just highlight one application. this is the best suitable for domestic load. That's why maximum domestic load use star connection, and this is suitable for delta. This is suitable for industrial load. So by chance 4 marks if there is a question, what is the connection between star and delta? So first you have to draw the circuit diagram, then voltage relationship, then current relationship, and finally the application. Star connection is suitable for domestic application and delta connection is suitable for industrial application. Thank you.